So yesterday we went back through simplifying radicals again. And we had a couple absences, so I'll just kind of walk back through this. I want to kind of start the warm-up off just to make sure you get how to do what we're doing. It's really about making sure, and it's going to get worse as you, not worse, it's going to get different as you move up. When you go into geometry and algebra 2 guys and pre-cal, it is all about following steps. It's just not the kind of math that you can just skip a bunch of steps like you used to be able to do and just figure it out and all the other kind of fun stuff. You have to be able to follow steps. You have to start setting up what am I going to do every single time. And I always start with good square root, bad square root. Okay? Set your good ones up on the left, set your bad ones up on the right. Break down each thing one number at a time. So when you break down 80, what's the good, bad square root split?
16 and 5.
16 and 5. 16 and 5. Now, what is it that makes a variable a good square root when the exponents are even? So one way to think about this is if you have x to the fifth, how many x's would you have to remove from x to the fifth so that it becomes even?
1.
It's 1. So once you remove the 1x and put it here, you set x to the fourth, which is a good square root on the left. Y to the first, all bad. Z to the sixth, all good, because it is an even exponent. And once you split it, good square root, bad square root, then you just have to find the roots. Square root of 16 is 4. Square root of x to the fourth is x squared. The square root of z to the sixth is z to the third. And everything on the right side should be a bad root, so it stays under that radical. And if you hear the term radical, radical is the name of this symbol. This is called a radical. Okay? Any questions? I know. Not really. Any questions? So here we have -3, and we're going to split it good square root, bad square root. Brandon, how do we split 64?
I know.
Devaney, how do we split it?
Put 64 on the left side and 1.
64 is a good square root. You don't freaking split it, for goodness sakes.
So I just
People.
Cool.
Oh, yeah, I just stayed.
By the way, just so you understand, if you like a square root of 100, we already know square root of 100 is 10. But you could split it into the square root of 25 times the square root of 4, which is 5 times 2, which is
10.
So you should end up at the same place no matter what. But don't split a good square root. It's just like we don't split the variables with even exponents. We wouldn't split that. So we have a to the fourth, that's all good. B to the seventh is not, so we take 1 out, which leaves us B to the sixth. And C to the 11th is not, so we take 1 out, and that leaves us C to the 10th. Now, right here, I will tell you that I usually go ahead and multiply -3 times the square root of 64. If that's a step that you're like, I'm going to screw that up, then you can rewrite it down with a line, no problem. But I always just go ahead and do square root of 64 is a. A times -3 is -24. Square root of a to the fourth is a squared. B to the third, C to the fifth, square root BC. And that's your answer. Yeah. And it's not that you wouldn't get it right, Brad. What I'm saying is there's no point splitting square root of 64. Oh, you didn't? Okay, good. Okay, any questions on that? And here we end up with 2 root. Let's see. Sydney, give me the good square root side after your split.
100.
Say again, 100. Perfect. Which leaves on the bad side 2pq. Right? So again, 2 times the square root of 100 is 2 times 10, which is 20. Q, r to the fifth, square root 2pq. 2pq. Okay? Any questions on that? All right. So what's the rule? Yes, sir? Because what is the square root of 100? Yep. That's what, that's why, and no, it's okay, because seriously, you're going to mess it up. If you're not bringing down that 2 each time and relying on you just remembering, most of you can't even remember to like pick up your clothes or close your dresser drawer. There's no way you're remembering to bring down a coefficient again. So, figure it out.
So
Spencer?
after we fill out the bad square root, we don't do anything with it anymore, you just bring it.
No, if you did it right, the bad, everything under the radical that's bad can't be simplified, it just stays under the radical. Okay? Number 4 and 5. What's the rule for adding radicals or subtracting? They have to match. So we know that this and this are going to have to match. So again, if you remember yesterday, I told you, I want you to do this, I want you to do this individually, and then you add them at the end. Okay? So we have negative 4 root 75, which splits into negative 4 root 25 root 3, which is negative 4 times 5, so negative 20 times the square root of 3. Over here, 3 root 48. We split into 3 root 16 root 3. 3 times 4 is 12 root 3. So we end up with negative 20 root 3 on the left. We end up with 12 root 3 on the right. When we add them up, we end up with negative 8 times the square root of 3. Okay? Any questions on that? Who got an answer for 5? Conley, what did you get for 5?
2 times the square.
Say that one more time.
2 times the square.
2 root 6. That's the right answer.
You put negative in the box.
No, that's not a negative. That's a ball cap.
So we could say that when we're checking our homework and it's negative, right? It's just a ball. But
Okay? Any questions on that?
It was minus and it's like.
It is negative?
Yeah.
Hold. Yes, hold. So, again, so I want you to do them individually. So 3 root 96 splits into 3 root 16 root 6. Square root of 16 is 4. So this is 4 times 3, so this is 12 root 6 on the left. Okay? On the right, we end up with 2 times the square root of 150, which is 2 times the square root of 25 square root 6. 2 times 5 is 10 root 6. So we have 12 root 6 minus 10 root 6.
it's
2 root 6. Guys, listen to me. Here's where you're making a mistake. Do not think of this as negative 2 root 150. I told you yesterday, I want you to do this number, then I want you to do this number, and then when you rewrite it, you put this subtraction sign in. That way you won't make a mistake. This just ended up being 12 root 6 minus 10 root 6, and that's 2 root 6. Make sense? Be very careful on those double negatives. That's why we don't deal with it. Don't do just simplify the number, and then do the math. Okay, so today we're going to do something called rationalizing the denominator. We're going to do something called rationalizing the denominator. I want to talk to you about it first. You cannot just change the value of a number. It's against math law. It's like a felony. You'll go to jail. Okay? Now, you can manipulate numbers, you can simplify radicals, you can do all those things as long as the value of everything remains the same. And I'll tell you what I mean by that. So like, on these, if you were to type this into your calculator and hit enter, and you were to type this into your calculator and hit enter, it will give you the exact same number. They're the same value. One's simplified, one's not. What is the only number that you can multiply another number by that doesn't change its value? 1. How many different versions are there of the number 1? A lot. Because if I write it in fraction form, how do I create any fraction that's simply equal to the same number over the same number, right? Same number over the same number. If I take 1/2 and I multiply it times 3 over 3,
that's 1 times.
I get 3 over 6, which is, I didn't change the value of my number. I just multiplied it for no reason times the number 1. Right? So here's what I need you to know. Whenever you have a fraction where there's a square root in the denominator, it's considered unsimplified. You can never give a final answer where there's a square root in the denominator of a fraction. It's considered unsimplified. So what we have to do is we have to move the square root from the denominator somewhere else through multiplication. So what I'm going to do to 2 over the square root of 13 is I'm going to multiply it times the number 1. It's not going to look like the number 1. It's going to be the square root of 13 over the square root of 13. Now watch what happens. Now if you remember back to multiplying fractions, the 6th grade thing, we do top times top and bottom times bottom. 2 times the square root of 13 is simply 2 times the square root of 13. Pretty complicated stuff. Now pick up your calculators and do the square root of 13 times the square root of 13 and hit enter. Nope, do it in the calculator before Glenn Box divorce. Ah. Well, no, because the square root of 13 times the square root of 13 is the square root of 169, which just so happens to be 13. Then you didn't see, look at me. Then you didn't move your cursor out of the radical before you multiplied it. Or you didn't close the parentheses. Watch this.
Yeah.
What's the square root of 4 times the square root of 4? Well, it's the square root of 16, which just so happens to be
Holy crap.
4. The square root of 4 times the square root of 4
It's
is 4. The square root of 8 times the square root of 8 is 8.
Oh, so whatever is the square root.
Whatever. If you're multiplying any square root times itself, it becomes the number under the radical. Just listen. Square root of 9 times square root of 9. What's the square root of 9? No, what's the square root of 9? 3. What's the square root of 9? 3. So the square root of 9, 3, times the square root of 9, 3 is
9.
9. Oh my God, I cannot help you. You're about to go into high school and you just said that out loud.
He said 6?
Uh-huh.
Oh, Lord.
So what it means, yeah, there's someone going, wait a minute, he's right. What?
Right?
Why did Master just drink so much? Oh, I don't know.
Oh, I don't know.
3 times 3 is 6.
Of course, Mr. Smith drinks.
I didn't say what I drank. I drank root beer and grape juice. Grape juice and root beer.
Wine and butter. No.
That's weird. Like ironic, almost. Okay. So what? So we do, listen up. So when we do top times top, we end up with 2 times square root of 13. When we do this, we end up with just 13. Guys, that's your answer. And it's a simplified answer because there's no longer a square root in the denominator. It's a valid answer. Now, interestingly, if you type this into your calculator and hit enter, it'll give you a decimal. If then you type this into your calculator and hit enter, it will give you another decimal that's exactly the same value. They are worth the same amount. One is just a simplified version of the other. So 1 over the square root of 17. What do we multiply it by to get the, yeah, we root 17 over root 17. So we end up with this. On the top, 1 times the square root of 17 is simply the square root of 17. Just 17 and your answer is done. That's your answer. It's called simplifying, it's called rationalizing your denominator. So watch this. This is where it gets interesting. In this fraction, which part of this fraction makes it unsimplified? The square root of 3. So we don't worry about anything else, but we go ahead and multiply it times the square root of 3 over the square root of 3, which again is worth 1, and we're not changing its value. So on the top, we end up with 27 times the square root of 3. On the bottom, you do the roots first. What is root 3 times root 3? It is 3 times 5, which is 15. And no, it's not. Because now, if you look at the numbers out front, they simplify. No, now I want you to listen to me. I'm going to talk to you as if you go to another middle school like Delano Tommy. If you want to simplify a fraction using the calculator because you're scared of real math, how can you simplify a fraction using the calculator? Math enter, right? So you could type in 27 divided by 15, math enter, and it will tell you that it's 9/5 because both are divisible by 3. So my final answer is 9 times the square root of 3 over 5. Do you want to get the answer right? I'm saying you use whatever tools are at your disposal. I will tell you though, like I told everyone yesterday, half your Algebra 2 test will not involve an electronic. So know how to do it. So try number 4 yourself, please. Rationalize the denominator. I want the square root of 11 out of the denominator on number 4. Take your time. Go slowly.
Simplify it more.
I'm not doing it.
Everything over 1 is just regular. Right 3 over 1.
Yeah, don't give me a fraction over 1, please. What you should have gotten is 2 square root 11 as the final answer. Okay? Same thing on 5. We multiply times root 21 over root 21, which gives us 7 root 21 over 21. But obviously 7 over 21 simplifies to 1 over 3, so you end up with the square root of 21 over 3. And again, guys, I want to be clear. The value of this fraction is the same as the value of this fraction. They're exactly the same. One is simplified and one is not. You just cannot give this as a final answer because the denominator has that square root. And again, finally on 16, what are we going to multiply it by? Root 5 over root 5, which gives us 15 times the square root of 5 over 15. Root 5 is 5. 5 times 3 is 15. Square root of 5 is the final answer. That's right. That's what's called rationalizing the denominator. Any questions? All right. Binomials using radicals. No, you may not use the box method. You're going to take the training wheels off the bicycle, and you are simply going to foil like real men. Eyes handled up with the second part. You would have started flapping your lips. So flap. Here we go. So watch. Now everyone pay attention and watch. So we're going to go ahead and foil. And remember, foil is first, outer, inner, last. So we go first 2 through multiplication. 3 times 2 is 6. Outside 2, we have 3 times the square root of 7. So it's plus 3 root 7. Inside is negative 5 root 7 times 2, which is minus 10 times the square root of 7. And then we have the last 2, which is usually where kids screw up. If we multiply the last 2, it's negative 5 root 7 times root 7. What's the root 7 times root 7 become? 7 times negative 5 is minus 35. Now, I'm sorry, go ahead, Jake. If you have negative 5 times the square root of 7 times the square root of 7, this becomes 7, okay? One step at a time. Now, we're not simplified because we have like terms. So we start with the first one. We have 6 minus 35, which is negative 29. And we have positive 3 root 7 minus 10 root 7. minus 7 root 7, and that is your final answer. Now, hold,
No, it's not.
it is. What I'm saying is, just like in mathematics, 4 minus 2x is the same as what? Negative 2x plus 4. I do not care about the order.
Okay, that was
I know it was. Because I'm smart like that.
He has a degree.
Okay? I have 98.67.
what?
98.
Stay with me, I'm moving quickly.
97.
Sorry, guys. The temperature is 98.6.
Oh.
I'm -5.
Okay.
Oh, you said you was on fire.
You're as cold as ice. Here we go. One more time, then we're going to have to do it. First alligator last. First, 20. Outside, plus 4 root 3. Inside, minus 5 root 3. Last, minus 3. Root 3 times root 3 is 3. Like terms, 20 minus 3 is 17. Plus 4 root 3 minus 5 is minus 1 times the square root of 3. And you don't have to have the 1 there.
Can you?
Yes, you can.
So it's 17 minus 33.
17 minus square root of 3. You go with number 9, please. Foil it. And I want to see that middle foil step every time. Because I need to know if you're multiplying wrong or if you're adding like terms wrong. Okay? So foil it first. And then simplify it down with like terms.
Yes, Mr. Smith.
Hey.
I think I got it. I think I saw it.
How do
You
you
get
use
no to
it?
32 plus 5 to square root.
No, plus 7.
Plus 7. How you
Yeah,
get it?
plus 7.
It is? Oh, okay.
First 2, which is negative 2 times 1. I'm getting there. Oh. Outside 2, negative 2 times negative 2 root 5. Is positive 4 root 5. Inside 2 is plus 3 root 5. And the last 2. Guys, when you're doing the last 2, if you need to do, because it's basically 3 root 5 times negative 2 root 5. If you need to write 3 times the square root of 5 times negative 2 times the square root of 5, do that. What's 3 times negative 2? Negative 6. What's root 5 times root 5? 5. If you need to do that, please do that. Okay? And your final answer is negative 32 plus 7 times the square root of 5. Any questions on that?
No, I just want to take my time.
All right. On the classwork, this is one that you have to know how to do this going into tomorrow. Tomorrow's Pythagorean theorem. We're going to be doing basically what we just did today with Chase. So practice this with your classwork and your keys, please.
What is interesting,
Yeah?
we have to have a question on the binomial with the like, they're all different.
Yeah. Yeah, you'll have them in all sorts of different words.
That's okay.